Alright, so this video is going to be on the kinematic equations worksheet. It's important that you guys understand how to do each and every single one of these equations. So before that, it's important for you guys to know where your reference table is. And if I haven't said this enough in class by now, you go to your classwork tab, go to reference table, click on the reference table, and we go down here and we see 3 equations. And these 3 equations, well, including this 4th one up here, right? We use these 3 equations. These are called kinematic equations. And we sometimes use this formula over here. V bar is equal to D over T. Now enough of that. Let's go on. So I'm going to explain how to solve for each and every single question. And before that, well, let's just write our equations up here, just so that I don't have to keep going back to my reference table, because that can get a bit annoying. You do not have to remember these formulas. They are on your reference table. So let's read number 1. In a race, a runner traveled 12 meters. So right, that's your distance. Length is measured in meters. That's distance or displacement. And your time is 4 seconds. And it says that she accelerated uniformly from rest. From rest means that you start with an initial velocity of 0. Sure, so you may have accelerated, but that's not acceleration. We don't know what acceleration is. Instead, the final question says, well, what is the magnitude of that acceleration? So what is A? Now let's take a look at, well, which equation do we use then? Do we use the first formula, right? The first equation, first formula? Sure, we have VI, right? We have an initial velocity. Sure, we're looking for A. Sure, we have T. But we don't know what VF is. We don't know what our final velocity is. So we can't use this formula. There's no way for us to solve for A. D, yeah, we have D, we have VI, we have T, sure. We're looking for A, and we have T. So we have everything we need in this formula. We have every single thing we need. We have all our terms. So we're going to use this formula to solve for our problem. Now let's, just for learning's sake, well, let's look at the third formula. Sure, we have VI. Sure, we have A. Sure, we have D. But we don't know what VF is. Again, we can't use VF. So we can't use the third formula. Let me just erase everything. So again, we're going to use D is equal to VIT plus 1/2 AT squared. So we're going to substitute all of our numbers. And 4 squared. So 12 is equal to 0, 1/2. 12 is equal to 0 plus 1/2, 16a. I'm just going to move it over, because you can do that. 1/2 times 16 is going to be 8, 8a, divided by 8. And what you're going to get is you're going to get 1.5 meters per second squared is your acceleration. And so B is the answer. So let's move on. 2. A truck. So from now on, I'm not going to go into how to pick equation. I already told you guys how to pick equation. Well, I guess I'll show you for number 2 as well. So number 2 says initially traveling at a speed of 22 meters per second. Right, so that's your initial speed. Increase the speed at a constant rate of 2.4 meters per second squared. So that's your acceleration. For 3.2 seconds. Now, it's acceleration because you see the unit. You see meters per second squared. That is always an acceleration unit. Let's say you didn't read the rest of this problem. You will always know that this is acceleration because of the unit. Velocity is measured in meters per second. Time is measured in seconds. Acceleration is measured in meters per second squared. And the question says, well, what is the total distance traveled here? What is the total distance traveled? So again, if we take a look at the formulas, well, we have VI, we have A, we have T and D, which means that our formula that we use must have all 4 of these variables. Which formula has all 4 of these terms or variables? And the only formula that has everything that you need is D is equal to VI T plus 1/2 AT squared. We don't have VF. We don't have final velocity, which means we can't use the other formulas. And this is the only formula we can use. So now I want to substitute for everything. And I get 3.2 squared. Unfortunately, I have to move over to the other side. So 22 times 3.2 is going to be a certain number. So if you solved, I guess I'll solve for you guys. 22 times 3.2 is 70.4 is equal to 1/2 times plus 1/2 times 2.4 gives you 1.2. And 3.2 squared is 10.24. Is equal to 70.4 plus 1.2 times 10.24 plus 12.288. And this is going to get you somewhere around 83 meters. Right? Distance is measured in meters. Number 3, what is the final speed of an object that starts from rest? So what's the final speed? So we want to know what VF is. Of an object that starts from rest, right? You're starting from rest, which means that your initial velocity is going to be 0. It accelerates uniformly from 4 meters per second squared. Right? We see the unit 4 meters per second squared. If you see that unit, that means that's acceleration. So your acceleration here is 4.0 meters per second squared over a distance of 8 meters. So which formula can you use? Again, you're looking at these terms. You have VF, you have VI, you have A, and you have D. If you match your formulas right here, well, let's say let's look at the first formula. We have VF, we have VI, we have A, but we don't have T. If we don't have one term, we cannot solve for the answer using that equation. So the only equation that you can use is the third one. This is everything you need. Now, starting from this question onward, I will not explain how to pick a formula again. I've talked about how to pick each formula already, which formula to use to solve the question. If you still have problems, feel free to email me, and I will help you during my work hours. So you solve everything, you simplify. You get VF squared is equal to 64. What you have to do after that is you have to square both sides, because again, you want to get VF by itself. And then you get 8 meters per second. And that is going to be your answer, A. Number 4, a car traveling east with a speed of 5 meters per second. So this is going to be your initial speed. It's accelerated uniformly at 2 meters per second squared east. So again, that's your acceleration. Acceleration is measured in meters. Is measured in meters per second squared. And your time is 10 seconds, as you can see here. So time is 10 seconds. During this 10-second interval, the car travels a total distance of what? So you're trying to figure out what D is again. Turns out you're actually going to use the same exact formula. Again, I'm not going to coach you on how to pick the formula anymore. I already coached you on. I don't know why it keeps I mean, I have an idea of why it keeps zooming in, but I have an idea. This is pissing me off. Okay, cool. So 5 times 10 plus 1/2, 2, and this is 10 squared. So we're going to simplify. 5 times 10 is 50. 1/2 times 2 is 1. 10 squared is 100. Let's go to 50. 50 times 50 plus 100. And we get 150 meters. Well, we don't have an answer in directly 150 meters. Instead, we have an answer in scientific notation. Well, how do we convert this to scientific notation? Right, so there's a decimal point here by default. And, well, we want to move it to the first digit. So what we're going to do is going to move this over. Right, there's a digit here. So we're going to move that decimal place over. What we're going to get is we're going to get 1.5. But since we moved it 2 places over, that means our exponent for our 10 is 2, right? It's 2 because you moved it 2 places over. And so the answer is going to be C. Number 5. Car increases its speed from 9.6 meters per second, so that's going to be your initial velocity, to 11.2 meters per second. And so that's your final speed. That's your final speed in 4 seconds. The average acceleration of the car is what? So the only formula you can use, because this formula has everything you need, right? We can't use the other formulas because it doesn't have everything you need. So we have VF 11.2 is equal to VI 9.6 plus A 4 minus 9.6. 1.6 is equal to 4A divided by 4. 0.4 meters per second squared. That's A. Hence your answer is A. Coincidentally. So 6. A race car starting from rest accelerates uniformly at a rate of 4.90 meters per second squared. Again, you know this is your acceleration because it says meters per second squared. The English hint is also accelerates at a rate of this. You also see starting from rest, which means that your initial velocity is 0. And so what is the car's speed after? So right, they want to find out what your final velocity is after it has traveled 200 meters. So your distance is 200 meters. And so the formula you're going to use is this. Right, so VF squared is equal to VI squared, which is 0, plus 2, which is 4.9, and D is 200. So VF squared plus 200, 400, it's going to be 1960. Okay. That's not a minus sign, by the way, guys. Let me see if yeah, great. Equal to 0. That's not a minus sign. And this is supposed to be 1960. So VF squared is equal to 1960. And we're going to square root both sides because, again, we want VF by itself. And what we're going to get is going to get 44.3 meters per second. That's going to be C. Number 7. A skater increases her speed uniformly from 2 meters per second. Right, that's your initial speed. 2.0 meters per second. To 7 meters per second, right? So you're going from one speed to another. Over a distance of 12 meters. So your distance is 12 meters. The magnitude of accelerations is what? Right? That's what they want to find out. What is your acceleration? This is a D, by the way. Don't be fooled. That's a D. So the formula we're going to use is VF squared is equal to VI is plus 2AD, right? It has everything we need. We know VF, which is 7 squared. We know VI, which is 2 squared. And we know A. Well, we want to find out what A is. We want to find out what A is. And we know what 12 is. Sorry guys, it's a bit scuffed. I know. It's a bit frustrating for me too, honestly. So now we solved this. What you're going to get is 1.9 meters per second squared is equal to A. Number 8. A child riding a bicycle at 15 meters per second accelerates at -3 meters per second squared. So your initial velocity here, they actually give it to you, which is 15 meters per second. And you're accelerating at -3.0 meters per second squared for 4 seconds. So what is the child's speed at the end of this 4-second timer interval? So what is your final velocity? What is your final velocity? So again, we're going to use this formula because as everything we need, VF, we have VF. Well, we want to find out what VF is. So VF is equal to 15 plus -3, 4. So 15 plus, well, it's going to be -12 because -3 times 4 is -12. And so VF is going to be 3 meters per second. So the answer choice is C. An object accelerates uniformly from 3 meters per second east. So VI is 3 meters per second to 8 meters per second east in 2 seconds. What is the magnitude of the acceleration? So acceleration is what? So VF is 8, VI is 3, plus A2. So you get 5 is equal to 2A. So I should disable Zoom somehow. I don't know how I'm doing it, but it's actually frustrating me. So that is the answer, 2.5 meters per second squared. A car traveling west in a straight line on a highway decreases its speed from 30 meters per second to 23 meters per second. So you're going from one speed to another. So you're going from VI, which is 30, to VF, which is 23.0 meters per second in 2 seconds. The car's average acceleration is what? So what is your acceleration? Again, you can identify the terms by the unit. So we're going to use this formula. 23 is equal to VI plus A2 minus 30, again -7, 2A, 2, -3.5 meters per second squared is equal to A. But what does this mean, right? It's not really an answer choice. There's no answer choice negative. But if you think about it, a car is traveling west, which means that the west in this question, west is positive. West is your positive direction in this question. Remember, usually we assume that east is positive. But in this question, it's saying west is positive instead. So this negative sign here, what we learned is that your negative sign is the opposite direction of your positive. That's what a negative sign means. A negative sign is opposite direction of the positive. So if your negative direction is your opposite direction of positive and your west is your positive direction, then that must mean your negative direction is east. And so the answer is A. 11. A rocket initially at rest. So there's something covering this. I apologize, but it does say initially at rest there. So initial velocity is 0. On the ground, lifts off vertically with a constant acceleration of 2.0 times 10 to the 1 meters per second squared. So your acceleration, and you know that's acceleration just by the units alone, is meters per second squared. And so how long will it take, right? It's asking you for the time. How long will it take to reach an altitude of 9 times 10 to the 3 meters? And it's measured in meters, so that's going to be your distance traveled. So this is what we know. And we're actually going to use this formula. We're not going to have enough room to write it though, which is unfortunate. So D is equal to 0. Actually, since 0 times anything is 0, we're going to put it at 0. So 1/2 2.0 times 10 to the 1 t squared So I'm going to rewrite it somewhere else. Rewrite it down here. So D is equal to VIT plus 1/2 AT squared. D is 9.0 times 10 to the 3 is equal to 0. 0 times anything is 0, so I'm not going to put that T there. A is 2.0 times 10 to the 1 NT squared. So you finish solving this. 1/2 times 2.0 is 1 times 10 to the 1. It's actually equal to 1 times 10 to the 1 t squared. 1 times 10 to the 1 is just 10 to the 1. So you get 9.0 times 10 to the 3 is equal to 10 to the 1 t squared. You divide it by 10 to the 1, divide this by 10 to the 1. What's going to happen is that I'm trying to search for room to write stuff. That's the thing. So when you do 9.0 times 10 to the 3 divided by 10 to the 1, the exponents subtract. What you're going to get is you're going to get 9.0 times 10 to the 3 minus 1, right? That's your exponent, is equal to t squared. So that's going to give you 9.0 times 10 to the 2 is equal to t squared. You square root both sides. Square root of 9 is 3. Square root of 10 squared is 10 to the 1. You get 10 to the 1 seconds is equal to t. And so the answer is going to be A. Answer is going to be A. Number 12. The speed of an object undergoing constant acceleration increases from 8.0 meters per second, right? That's your initial speed, to 16 meters per second. So you're going from one speed to another. And we know it's speed because it's meters per second. And it does that in 10 seconds. So the question is also says, how far does this object travel? So what is D? Now this is one of the rare questions rather. Now you're going to use this formula. V bar is equal to D over T. And you know that V bar is equal to average speed or velocity. And so, well, how do we get the average of two numbers? Well, to get the average of two numbers, you add them both and then you divide it by 2. Well, how do you get the average speed? You get the numbers of both speeds, 8 plus 12, and then you divide it by 2, and that's how you get your average speed, right? You add up both of your speeds and then you divide it by 2. So what you're gonna get here, oh, this is actually 16. Can I edit that somehow? Is that possible? No, I cannot. So I'm actually just gonna delete this part. So VI is 8 meters per second. VF is 16 meters per second. So V bar is equal to 8 plus 16 over 2. And that's going to give you 12 meters per second. So that's your average velocity. This is your average velocity. And now we're going to use this formula, right? V bar is equal to D over T, right? Average speed. So we're going to plug in all our numbers. D is question mark, T is 10. Multiply by 10 on both sides. What you're going to get is you're going to get 120 is equal to D. Well, we add the meters there. Well, there's all our answer choices are in scientific notation. Well, how do we convert to scientific notation? Well, we want to move our decimal point to the first digit, and we move the 2 spaces, and so we get 1.2 because we moved our decimal over, and we moved it over 2 places. So the exponent we have to give our 10 over here is 2. We moved it over 2 places, 2 spaces, and so that's our answer. Number 13. A car accelerates from rest, uniformly from rest, VI is 0, to 15 meters per second over a distance of 100 meters. The magnitude of the car's acceleration is what? And so when you use this formula, $15 squared is what is that? Is that 225? We'll know soon enough. 2 times 100, 200A. 15 squared. 15 squared. 15 squared. It's 225. And then we divide this by 200. And we should get 1.1 meters per second squared is equal to A. 14. The speed of a wagon increases from 2.5 meters per second to 9.0 meters per second. So you're going from one speed to another. In 3 seconds. So time is 3 seconds. As it accelerates uniformly down a hill. We actually don't care about that. So what is the magnitude of the acceleration? So we're going to use this formula. 9.0 is equal to 2.5 plus AT. So minus 2.5. Actually pissing me off. 6.5 is equal to 3A divided by 3. We get 2.2 meters per second squared is equal to A. Alright. Now number 15. Initially traveling a road at 15 meters per second. Accelerates uniformly to a speed of 21 meters per second in 12 seconds. The total distance traveled is what? So this question again, you're going to use a V bar is equal to D over T. So what's the average of 2 numbers, right? What's the average speed? Well, you add up both speeds and then you divide it by 2, and that's V bar, right? That's V bar. is equal to d over t 12. So 15 plus 21, 36 divided by 2 is going to give you 18. D over 12 times 12 on both sides. And you get 216 meters is equal to d. And that's your answer. Okay, cool.